नमस्ते, सत श्री अकाल, गुड आफ्टरनून। आई थिंक जो प्रेजेंटेशन बनाया था मिस्टर अमित ने, उनका इन्वेस्टिगेशन एंड प्रेजेंटेशन उसके बाद बहुत ही तारीफ़ काबिल था। तो मुझे लगता है एक जोरदार तालियां हो जानी चाहिए उनके लिए। थैंक यू। प्रेजेंटेशन पे आते हैं। क्विकली अबाउट मी, एक्चुअली आई हैव 35 years of experience in plant operation, projects, safety, process safety. We are the company HSA group of companies having almost 20 years of experience, and we have the internal exposure for the risk engineering, Occidental of Oman, PDO, ADNOC, Kuwait Oil Company, different companies we are working. We are launching HSA Process Safety Academy for 1 year postgraduate diploma in process safety management. As I said that founded in 2006, we have 20 years of experience. These are the highlights of our projects. Total HSA studies project conducted until January 2025, it's a 1,000 plus. We are conducting almost 48 types of studies. We have presence in 10 countries, 140 clients, and 26 types of industries. Regarding the major studies, HAZOP conducted 620 plus, HSA 55 plus, QRA 25 plus, and safety training 120 plus, project HSA review 150 plus, hazard 150 plus. These are the few of our HSA studies which we are doing regularly. Title, Introduction to LOPA. So what is LOPA? Actually, if you recall the incident investigation of this ANFD, so there were different layer of protections were missing, and they introduced later on after the investigation. So quickly we will try to relate this presentation with the incident investigations also. So basically what is LOPA? It's a simplified risk assessment method built on the PHA findings. So simplified risk assessment methods, we can use the Microsoft Excel also, can use the softwares like PHA Pro and any other softwares. So build on PHA findings. So basically, initiating point for LOPA, we can say a HAZOP study for process, machine risk assessment for machines. Like that, we can have different risk assessment as a initiating study or initial study of findings we can use for the LOPA. So check, basically the objective of LOPA is to check the adequacy of the safeguards and need for the extra layers. Reference, you can have CCPS, layer of protection analysis, simplified process risk assessment. You can use this for understanding the LOPA. And then what is the importance of this LOPA in the PSM? So basically it supports OSHA PSM compliance. So you know that basically in OSHA we have 14 elements, and out of that we have one element, PHA, process error analysis. So LOPA is one of the study in the PHA, right? Normally we do after the HAZOP. So again, for this also you can refer the OSHA PSM guidelines. Okay. Now regarding the comparison with other risk assessment tool, if we say we have the HAZOP, we have the LOPA, and we have the QRA. So what is the basic difference between HAZOP, LOPA, and QRA? So HAZOP, normally it's a qualitative, we know it's a qualitative. Sometimes we call it as a semi-quantitative, right? The purpose of HAZOP, we know that to identify the hazards, deviations, and use of safeguards. Basically, we do HAZOP in early design stage or maybe after the detailed design also, with the help of the P&ID, cause and effect, and some other informations. And basically, during the operation, we do the cyclic HAZOP. That is regularly every 3 years or 5 years based on the company guidelines. Now, coming to LOPA, basically, it's a semi-quantitative again. The purpose of LOPA is to assess adequacy of IPLs, independent projection layers, and estimate the risk, validation of the deviation. In general, to LOPA, we can say we validate each deviation. Comparing to HAZOP, we can say validate the process with respect to safety. So HAZOP, we can say validation of process with respect to safety. LOPA, validation of each deviation with respect to interpreted IPL, that is protection layers. Coming back to QRA, it's a quantitative, purely quantitative. We use modeling, so model risk numerically and in detail. So we get the fire distance, safe distance through the QRA. Basically, this is a high value, high risk projects. Now, the first terminology in the LOPA is independent protection layer, and we use safeguard in the HAZOP. Normally, safeguard you can call it as a controls and barriers also. Different terminology used in different industries. So basically, what is the basic difference between safeguard and independent protection layer? So safeguard is a device, system, action interrupting Event chain after initiating event. I is the initiating event, effectiveness and not quantifiable, not an IPL. So basically safeguard, you can say, if you don't have the backup records, you don't have anything to audit, then also we can consider control as a safeguard. Say for the example, we have the SOP, but we don't give the training for the SOP. In HAZOP safeguard, in safeguard we can consider the SOP. But when we come to the IPL, independent protection layer, so there are some guidelines. Like IPL, as we know, it prevents the consequence independent of initiating event. So IPL should be independent of the preempting layers. Auditable, should have the records, should have the proper data, and proper training, proper regulation should be there. And validated effectiveness and known probability of failure or demand. PFD is a probability of failure on demand. So basically, IPL is, we can say, well-defined control in the process. We reduce the probability of failure to the IPL. Safeguard, of course, we cannot say it's effective or not, but when switch over to IPL, so definitely. So nowadays, industries, they don't do the LOPA. So they use IPL concept in the HAZOP itself. So if you use IPL concept in the HAZOP itself, so that will be helpful to you if you don't do the LOPA also. But of course, we cannot completely replace using IPL in the HAZOP with the LOPA, but partially you can say that will be effective. Okay, now objective of the LOPA. Basically, risk reduction is the first objective of the LOPA. So identifying the gaps in the protection layers and reduce scenario risk to tolerable level. Basically, tolerable level, normally you might have heard the terminology ALARP. So that is the basic concept. So identifying the gap, that is the first thing, and reduce the risk of the deviations. So that is the first objective of LOPA. Second, decision-making support. So normally provide a semi-quantitative basis for prioritizing the safety investments and selecting control measures. So again, you can use IEC 61511 for these things. The last objective is to determine need for additional safeguards. So that is the basic objective of the LOPA. Evaluate whether existing IPLs are sufficient or if new safeguards are required. So that is the base for the LOPA. That is why I just called it as a adequacy, to check the deviation adequacy with respect to the safety. Because while doing the HAZOP study, we identify the existing safeguard, and if required, we give the recommendations also. But all these safeguards or recommendations are adequate or not, that we check through the LOPA. So very important exercise in this risk assessment. Okay, now when to use LOPA? So after HAZOP, I just said in the beginning that after the HAZOP, we do the LOPA. Then we do the seal if required. So this is a sequence basically. So after HAZOP or similar quantitative analysis, like for process, we can say HAZOP. For machine, it's a machine risk assessment. Similarly, for other activities, we can follow. So applied once hazards and initiating events are identified to quantify risk and evaluate protection layers. So basically, there are slight differences in the terminology in the HAZOP and the LOPA. Say in HAZOP, we list out the causes. So causes are initiating event in the LOPA. That is the basic thing. Terminology is different. Everything is the same, right? So second thing, for scenarios involving high consequence events. So basically, how we select the deviations. So basic concept of selecting the deviation from the HAZOP study or any other risk assessment is, we have to check high severity consequence of deviation. Like if the high severity means severity, if we are using 5 by 5 risk matrix, so 4 and 5 severity can be used for the LOPA as a input. So basically, we have to identify the 4 and 5 severity deviations. Then we have to take in the LOPA worksheet and we do the LOPA analysis there. So that is the basic thing for scenario involving the high consequence only. So we are not addressing the low or medium normally severity scenarios here in the LOPA. Our address is to control, prevent or mitigate the high severity catastrophic release and all these things. Okay, so next thing is when we use LOPA, when required by regulatory or corporate standards. So basic regulatory requirement may be OSHA, maybe IEC or company standards, corporate standards or national standards. Basically in Indian standards, there is one IS, but that doesn't mention that LOPA is required. They just say that risk assessment. Even you refer the Factory Act, Factory Rule, Manufacturing, Storage, Import of Hazardous Chemical Rule. So they say that risk assessment is required. So as I said that LOPA is the next step for the HAZOP. So definitely, if company policy is there, so we should do the LOPA also whenever risk assessment terminologies comes for the evaluation. Okay. Now coming to the initiating event. So basically, initiating event, as I said, that it's a call for the HAZOP. So basically, we directly take calls from the HAZOP and we write down it as an initiating event. So basically, device, system failure, external event, human error. Basically, that is the basic initiating event. So let us take one by one. So device or system failure means we can say failure of the scrubber. That can also be the control. Device means we can say shutdown system. External event may be the fire, maybe the environmental. Human error. So human error, I will not touch more here because later in the next lecture you will have the detail of the human error. But we can say inadvertent closing of the any isolation valve. That can be one of the human error. So IEF, initiating event frequency, normally unit is events per year. So that is the first thing. We take IEF, then consequence. Second parameter is consequence in the LOPA. So consequence same as in the HAZOP. Safety, environment, property, business impact. Normally what happens, we start with the initiating event, then there is escalation of 2, 3, 4 steps, and then we have the final consequence. So normally in the world, final consequence should be in the 4, max. Normally, you may have the additional categories, but first is safety, may relate to human and other factors. Second, environment. Third is property, asset damage. Fourth is business interruption, or you can say a repetition also. Right? So next one is basically independent protection layer. That is the basis for the LOPA. So independent protection layer is independent, auditable, and have known probability of failure on demand. So PFD, normally we can find the PFD. There's a table in CCPS LOPA book. There's a table, I think 3.2. There you can find the different PFDs for different controls. So like for shutdown system, it's a once in a 10 year, or you can say PFD 10. For PSV, it's a clean service, so it's a 100 PFD or once in a 100 year. So that is a frequency. There are a few rules for the IPL. We can say that first thing is auditable, then should be, we can say, suppose we have the two transmitter on the equipment. One is pressure and one is temperature, and controlling system control valve is 1 to 2 in case of any abnormality. It close one control valve means there is only one independent protection layer. Transmitters are there, detection systems are there, but control is one, so it's only one independent protection layer. So there should be independent, or we can say redundancy in the availability, right? So next one is mitigated event frequency. There's a formula, MEF, that is mitigated event frequency, that is equal to IEF, that is the initiating event frequency, which normally we measure in events per year, and PFD, probability of failure on demand of each IPL. So we multiply each IPL PFD. Later on in case study, we will see this, how we calculate it. So normally we multiply each PFD with the IEF, and that is the actually mitigated event frequency. And calculated mitigated event frequency, we compare with the company guideline. Say for some company guideline, it should be in between 10⁻⁴ to 10⁻⁶. So that is what we call ALARP, as low as reasonably practical, right, or kept possible. So that is the ALARP. So say for some company, it's a guideline that ALARP should be in between 10⁻⁶ to 10⁻⁴. So that we compare with the actual result. If within the ALARP, that's okay. If more than ALARP, so then we have to again add the one or more IPL as per the requirement, and we again have to recalculate this. So in the software, normally automatic calculation is there. So just we have to add the IPL and check whether this IPL is adequate or not. So like this, we calculate the basically mitigated event frequency to achieve the ALARP. So this is the basic risk matrix normally we use. So we have a risk tolerance criteria, risk matrix. In the risk matrix, normally we have the probability, we have the consequence severity. The severity can be described in the asset damage, human effects, environmental impact, reputation of the company, delay. You may have the as many as categories you want to describe. So basically, you can refer CCPS risk analysis screening tool manual, RASH manual, for preparing this risk matrix. If you have available risk matrix, that is fine. Otherwise, you can prepare on your by referring this manual, RASH manual. Okay, now coming to the LOPA methodology. So step by step, already described, but let us summarize it. So first step is to select the scenario from the HAZOP or any other PHA study. So in the HAZOP study, we just select the scenario. As I said that in case of 5 by 5 matrix, high severity means 4 and 5 severities deviation. We select it, we identify it, and just transfer it to LOPA worksheet. So that is the first step. Second step is identifying initiating event frequency. So our initiating event in case of LOPA is again cause for the HAZOP. So same thing directly we copy paste and do just mention it, and we check the failure frequency or initiating event frequency. Again, from the CCPS book, same book you can find out. Otherwise, you can find from the different OJPs for the failure frequencies also. So these are the two references available. From that, you can check and write down the initiating event frequency. Next, third step is identify IPLs and assign PFD. Say, again, identifying IPL is very critical here. You may have different safeguards, but you have to validate the safeguard first before taking it into the consideration of the IPL. So for the example, you have the training as a safeguard. But again, if you say training as a safeguard, it means when we check for the LOPA means we should have pre-post evaluation, we should have documents, records, everything should be available. We have the SOP means proper training. Training means again these things. Training, properly identified need, we have training metrics, training planner, pre-post evaluation, records for that evaluation, and passing criteria. All this combined make an independent layer. If these systems are not there, means that is a safeguard, not an IPL. So like that, we have to identify out of safeguards which are IPL. Next step, fourth is calculate mitigated event frequency, same as I discussed, that multiplication of initiating event frequency into available IPL, right? So then after multiplication, we have to compare to the risk tolerance criteria. For me? This is for me? Okay, fine. So quickly definition of IPL, this is just example you can say, as I discussed definition of IPL, I will not spend much time of it because we have to see the case study. So this is a pictorial diagram. Basically in a code, there is a process and basic process control. From third layer all up to 9 is a protection layers, but you have to see whether IPL, that is IPL or not IPL, right? Risk criteria and target frequencies. So ALARP I already discussed, so will not spend much on this. Case study. Now, coming back to the case study, just I will explain this and then I will request to open the case study file. So, case study is related to the plant under study, consists of a melter gasifier system generating syngas that flows through the hot gas cyclone, reduction shaft, top gas scrubber, top gas venturi scrubber, and top gas mist eliminator before reaching export gas one. A prior HAZOP study identified potential deviations and process hazard in the gas flow and system pressure. We'll take one deviation here. So hazardous scenario is from the HAZOP deviation, initiating event of course from the HAZOP case cause, scenario summary and consequence. That let us have the worksheet so you can have the clear understanding. So please open the case study. So this is the LOPA worksheet. Thank you very much. So this is the LOPA worksheet. I hope you can read or need to zoom in. You want to zoom in? Slide zoom in, please. Slide zoom in so they can read. I think slide zooming is required. Please. Okay, thank you. Hope you can read it. Anyway, just I explain quickly. If you see LOPA sheet legend, that is top on the left, LOPA sheet legend. So we have some legend like headings with the blue color, manual entry with the white color cells. All cells mentioned here, if heading means blue color, similarly manual fields white, you can refer that legends. Then date of the LOPA assessment, that is a reference. Then we have the hazardous scenario. Hazardous scenario means it's a consequence of the HAZOP study. So here, it's a deviation. So a hazardous scenario is a deviation, So it's a deviation means no less flow of generator gas from the melter gasifier to the export gas. So that is the deviation. Again, scenario number we can mention as per our policy. Coming back to the scenario summary, so increase, that is a consequence in the HAZOP. So increase in the system pressure in the upstream of the top gas scrubber may lead to damage and release and of course further explosion hazard. So supporting information, you can just define the design pressure of the melter gasifier. All that you can mention is supporting information. Here, initiating event is a cause. The top gas scrubber wooden packing batch jamming. So that is the cause, or you can say initiating event. So from here, actual LOPA start. If you go to the right, so we have mentioned the 0.1, that is the 10⁻⁻1 failure frequency of the initiating event. That is taken from the reference book. So that is the first step of the LOPA. Then second part, if you go enabling conditions. So there are different enabling conditions that may present during the operation. So that is first is a time at risk. So suppose we have the batch process. So in the within 24 hours, that operation may take for the 8 hours. So here you can say 8/24 is a time at risk. For the conservative approach, here we have taken 1 for calculation. Just go to the right, so here we have taken the 1. But based on the availability of that process, this process of time at risk, like 8 hours in a day, 24 hours of the day, so 8/24 will be the ratio here. Please go back to the left. So campaign. So campaign may be 6 months in a year. So you can consider 6/12.5 can be the ratio. So as a conservative approach, we have taken all these 1, 1, 1, 1 for our conservative approach. But you can add if available informations are there. Now second part is conditional modifiers. So different conditional modifiers we use to specify or make it accurate LOPA study. So first is the probability of the hazardous atmosphere. So after release probability of hazardous atmosphere that you can calculate through the QRA, and from that you can refer it here. Second part is probability of ignition or initiation. So ignition, probability of ignition, you can refer OGP for the probability of ignition, or QRA also if QRA is already done. Based on that, you can consider here the probability. But for conservative approach, again, we have taken 1, 1, 1 for all these things. Next part is probability of explosion. So same, you can consider reference books for the probability of explosion. Again, we have considered 1 here. I think you can keep this. That's fine. Yeah. Slide right. Okay. Probability of personal presence. So again, manned site, unmanned site, based on that, you can consider the probability of personal presence there. So for conservative approach, again, 1 considered. Probability of consequence, same thing. And others, if any other parameter is there that you want to consider to make it more accurate. So this is the second conditional modifier. Then we move to protection layer. So that again from the HAZOP study. So we have different safeguards in the particular HAZOP, but we have considered only the shutdown systems which are applicable and independent protection layers. If you please shift to the right, please. Slide to the right. If you see in the first, that is the first is a shutdown system, interlock. So we have considered failure frequency 10⁻⁻1 or PFD 0.1, right? Second, 5 minutes, 2 minutes on that. Second is low temperature. Again, because it's an interlock, so we are considering it. Third is alarm, fourth is alarm, not independent, so we are not considering. And on conservative approach, we take it as a 1. And fifth, again, it's again control system, so we have considered 0.1. Please slide, move to, yes, scroll down, please. So now, based on the calculated feed, if you see residual event frequency after risk reduction, that is 1 into 10⁻⁻5. That is, and again, tolerable maximum mitigated event likelihood 10⁻⁻5. So target is 10⁻⁵. Calculation, based on calculation, it is 10⁻⁵. So we doesn't require any other layer. So that is a basic sample calculation. If we receive 10⁻⁴, then we have to add 1 protection layer to make it safe. So this is the way we do this LOPA. This is one case study. I hope I am able to explain in proper way. It's a very short time, but of course, good to understand. So thank you very much for allowing me to share this presentation. Thanks a lot.